Welcome to CSEGuru. In this session, we will discuss the topic recursion. Recursion is a function that calls itself. Any function that calls itself, that is calling the same function again and again within the user-defined function, in the sense that is nothing but recursion. For example, if you are considering the function void add, okay, and this is the statements within the user-defined function. And inside the function, this is the user-defined function, and inside the user-defined function, again, if you're calling the function add, that is, the function addition calls itself. Function calls itself during execution is nothing but the recursion. So recursion is a method of solving a problem where the solution to the problem depends on solution to the smaller instance of the problem. Suppose if you are using this user-defined function, in the sense, this user-defined function will call the same function again inside the same user-defined function. Okay, so here if you are considering, in the sense, if you wanted to find a solution to the smaller instance, when you are calling this user-defined function, in the sense, it will be a big problem. Again, when it is called inside, in the sense, the problem will be reduced somehow to the smaller size. Okay, so again, when it is called, in the sense, again it will be reduced to smaller size. So, if you wanted to find the solution to a smaller instance of the problem, in the sense, in that case, we will use a recursive function. So, this is the process of repetitive computation. Already we know iterative computation. So, iterative computation is nothing but the looping statements. The for loop, while loop, do while loop, that and all the looping statements. It is nothing but the iterative computations. That is, until the condition is true, it will execute this for loop statement. Okay. When the condition fails, in the sense, it will comes out of the loop. So these are all the iterative statements. For loop, while loop, and do while loop, if you are considering, in the sense, these are all the iterative statements. And the recursive function is nothing but the repetitive statement. That is the repetitive computation. So each action is stated in terms of previous result. Okay, so some value we will pass it here, and that value it will carry, and inside, if you are considering, in the sense, this function will execute only based on the previous result of this user-defined function only. Okay, so this is nothing but the repetitive computation. So recursive function is nothing but the repetitive function execution. Okay, so the function calls itself is nothing but the recursion. Next example to implement recursion. The best example to implement recursion is factorial. Already we have discussed the concept and logic of factorial function. Now we are going to implement the factorial function using recursion example. So this is the header file, and this is nothing but the function prototype. That is function declaration. And this is the main function, and inside the main function, n and factorial. These two are nothing but the local declaration for this main function. And here we are entering the number n. And this is fact of n is nothing but the function call. So this n is the parameter we are going to pass. Here in function call, this n is nothing but the actual parameter. So when a function is called, in the sense, immediately control will be transferred to the user-defined function. So this is the complete user-defined function, and it will execute the complete user-defined function. Once the user-defined function completes its execution, immediately control will be handed over again to the function call. This is the logic. So here we need to enter n value, and n is the parameter we are going to pass from the calling function to the called function. For example, if n value entered here is 5, in the sense, the value 5 will be passed from the calling function to the called function. And this user-defined function is the called function, and this is the complete function definition. And here, this n is nothing but the formal parameter. In function called, this n is the actual parameter. And here in function definition, that is the function header of function definition, this n is nothing but the formal parameter. So when the parameter is passed, in the sense, the user-defined function will create a copy of the actual parameter. And that copy of the actual parameter is nothing but the formal parameter. So here n value 5 is passed. So now we will trace the logic for this recursion example. So here n value is 5. It will check the condition whether 5 is equal to 0. Condition fails. It won't execute this statement. So it will go and execute this return statement. So this is the first recursion. So what do you mean by recursion? A function. So this is the function name. Fact is the function name. A function calls by itself. This fact is this function name only. So a function called by themselves or function calls itself is nothing but recursion. Here we are not calling any different user-defined function. The same user-defined function we are calling again and again until the condition is true. Okay, so this is the recursion concept. So when this return statement execute, the first time when this return statement execute, this is the first recursion. So here n into fact of n minus 1. Okay, n into fact of n minus 1. So here n value is nothing but 5 into fact is nothing but the user-defined function, fact of n minus 1. So fact of 5 minus 1, that is 4. Okay, so this value it will store it in memory and this user-defined function again it will call. This is the concept of recursion. So this user-defined function again will be called. Okay, so again it will go and execute the same user-defined function with the n value 4 because here fact of 4. Okay, so with the value 4 it will execute the user-defined function again. Now first recursion is over. So second recursion if you are considering in the sense whether 4 is equal to 0 condition fails. It will go and execute the return statement. So return statement is n into fact of n minus 1. So previous recursion already value 5 is there. So 5 into n into fact of n minus 1. Okay. So here previous recursion value 5 is there. 5 into current recursion value 4 is there. 4 into fact of n minus 1. That is 4 minus 1 is 3. So now again with n value 3, it will execute this user-defined function again one more time. Check the condition whether 3 is equal to 0. Condition fails. So it will go and execute this statement again. This is the third recursion. So here already 5 into 4 is there. So 5 into 4 into n into fact of n minus 1. Okay. So 5 into 4 into 3 into fact of n minus 1, that is 3 minus 1, that is 2. Okay. With the n value 2, again it will execute the user-defined function one more time. To check the condition whether 2 is equal to 0, condition fails. Again it will execute this return state. So this is fourth recursion. So 5 into 4 into 3. So these values we have got from the previous recursion. And currently n into fact of n minus 1. So 5 into 4 into 3 into current n value is 2 into fact of n minus 1. So 2 minus 1 fact of 1. With n value 1, again it will execute the user-defined function one more time. It will check the condition whether 1 is equal to 0, condition fails. It will go and execute this return statement again one more time. And this will be considered as fifth recursion. Okay. So in fifth recursion, previous recursion values are 5 into 4 into 3 into 2. And current recursion if you are considering, that is n into fact of n minus 1. So n value 1 into fact of n minus 1, that is 1 minus 1 fact of 0. Next, with n value 0, again it will execute one more time. It will check the condition whether 0 is equal to 0. Yes, condition is true this time. Now it will return 1 for this fact of 0. So, sixth recursion, fact of 0, the value it will return 1 here. Now, the recursion concept is over because the function execution is completed. It will return 1 and it will exit this user-defined function. So now it will return the value. That is 5 into 4 into 3 into 2 into 1. We will get it as 120. And this 120, it will return here. That will be copied to this variable factorial and it will display in the output screen. 120 will be displayed in the output screen. So here if we are considering in the sense, recursion is nothing but a function calling by itself. The same user-defined function calls itself. That is nothing but recursion concept. So this is the best example, factorial function. Next, if we are considering the advantages and disadvantages of recursive function, these recursive functions are easier to implement. Since the function calls by itself, it is easy to implement. And also, it is very efficient. It will reduce the number of code because it is not necessary to repeat the user-defined function again. Simply with one function call, it is enough to implement the complete user-defined function. Okay, it is not necessary to write the code again and again. And we can able to create a very clear and simple functions. Okay, and disadvantages if we are considering in the sense it consumes more memory because previous recursive values also it needs to restore. And at the end of the completion of the user-defined function only, we will get the result. We need to calculate the result. So it consumes more memory to restore the previous recursive values. Okay. And it is a slower execution compared to iterative function. Iterative functions are nothing but the loops. Okay. So compared to the iterative function, it is slower in execution and it takes more time to execute. So these are all the advantages and disadvantages of recursion. Thank you for watching this video.